Good day and welcome to my YouTube channel. I am Arthur Francis Deban. Today we're going to be taking a topic: qualitative inorganic analysis. Qualitative analysis in general is the part of chemistry practical that deals with determination of constituents of substances, whether organic or inorganic, which means we have organic qualitative analysis and we have our inorganic qualitative analysis. But our business today is inorganic qualitative analysis. Our main focus now is inorganic qualitative analysis, which involves identification of anions, which are acid radicals, such as NO3 minus, SO42 minus, CO32 minus. All these are acid radicals. And cations, which are metallic radicals, such as zinc 2 plus, aluminum 3 plus, and so on and so forth. Of unknown inorganic salt, the practical will be given to you in terms of sample A, for example, which means you don't know what sample A is, only the instructor knows. So it is unknown. Now, there are peculiar characteristics that will be exhibited by sample A that will prompt you to say it is either zinc or aluminum or sodium, and so on and so forth. Results are recorded under headings test, observation, and inference. Precautions in qualitative analysis. So let's start with the precautions. You know the precautions before we can go into the main business. Now, 1, use clean apparatus in carrying out qualitative analysis. The apparatus must be very clean. 2, use small quantities of the reagent. All right, very small. Use boiling tube as a test for heating. Now, always hold the test tube in a slanting position when heating. Slanting, not straight. You are using your test tube holder, you slant it when heating, so that the gas goes out this way, not directly to where you are. When identifying the odor of the gas, do not inhale the gas directly, as some gases are poisonous. Okay, you hold it in a slanting position, you tap the air a little bit that you can smell it. Don't just take it to your nose. Most of them are very poisonous. When heating, do not fill the test tube to more than half of its volume. So the test tube must be filled, not up to half. Take note of that. Use distilled water in diluting or dissolving your samples. All right. 8. In most cases, delivery tube should be used in passing a gas to a solution. And 9. Follow instructions strictly. An addition of reagents should be sequentially. All right. The instructions therein should be followed strictly. If you do not follow the instructions, you're likely going to miss out. Now, our first title here is the preliminary test. Preliminary test is poised to identify cations, anions, sublimates, water of crystallization, and gases in the salt under analysis. So our preliminary test is focused on identifying the cations, which are the metallic ions, the anions, the acid radicals, sublimate, substances that when heated in solid state moves directly to gaseous state, iodine, solid ice or dry ice, let's put it that way. Water of crystallization, the quantity of water present in the sample, we did that in our previous work, and gases in the salt under analysis, and the various gases present in the salt, like CO2 found in chlorocarbonate. Now, preliminary tests include the physical properties. Remember, preliminary test deals with the identification of cations, anions, sublimate, water of crystallization, and gases in preliminary tests. All right. Now, in that preliminary test, they include physical properties of the substances, flame test, and action of heat. So, under the preliminary test, we'll begin to look at the physical properties, which we can now look at the sample to identify what sample is, what the sample is, the content of the sample from the physical properties. And flame test, which we're going to deal with that too, and action of heat. Now, let's look at the physical properties under preliminary test. The physical properties under preliminary investigation refer to the texture. How does it feel? Texture, color, odor, and the solubility of the sample. All right. So under the physical property, we're looking at the texture, the color, odor, and the solubility of the sample. Let's start from the texture. Before undertaking any test, one should closely look at the texture of the solid to identify whether it is amorphous or crystalline in nature. So that is what we're looking at the texture. I've given you sample A to identify. The first thing that comes to mind is, what is this? What is the texture of it? Is it amorphous or crystalline? Is it solid or powder? All right. Amorphous means the solid is without shape, that is in powder form. While crystalline means the solid has shape, that is crystal in nature. So that is what happens in the texture. Now, we have to carry out texture under observation and inference. All right. Remember, we said our business is test, observation, and inference. So we want to look at the texture. What if it is solid? What if it is powder? What exactly should we be expecting if it is either of these two? All right. So now let's look for the observation and inference for texture. Now we say when substance or mixture is crystalline, which is solid, all right, we say water of crystallization is obviously present, all right. Solid samples, the inference, what comes to mind? Now, how does that go? I've given you sample A to analyze. Before you start putting it into the test tube, first you carry out the physical properties, which is the texture. The texture here goes with either it is solid, crystalline, or amorphous powder form. Now, what I've given to you first is solid. Now, the first thing that comes to mind is, oh, okay, it is solid. There is water of crystallization. Potassium, sodium, or ammonium ion are visibly present or possibly present. Now, this has given you an insight of what you should be expecting when you proceed further to put it into your test tube, add this or add that as the instructions will further go. But from what we have seen so far, you've been able to narrow down to this level that these three guys could possibly be present, and you take note of that before you proceed further. But whether substance or mixture is amorphous, which means it is in powder form, CO3 minus or HCO3 minus salt of non-alkali metal present. We have the alkali metal, alkali earth metals. Alkali metals, we have the sodium, potassium, alkali metals. Alkali earth metals, we have the calcium and magnesium and so on. This is non-alkali metals. So we will be looking at calcium plus carbonate 4 or magnesium and so on present. So by our texture, this is where we are. So we'll move further to see what we get further. So in color, let's look at the color now. We're done with texture. B, color. A close observation of a solid will give a possible hint on the cations or anions present. All right? A close observation. You're looking at the solid closely. You want to know what color does it possess. So we're going to look at color under observation and inference, just like we did in that of a texture. So let's look at the color. The color under observation and inference, we are having observation, okay? We have white color or colorless. So the sample given to you is white. The first thing that should come to mind is it could either be calcium, lead, zinc, aluminum, sodium, magnesium, and ammonium ion, because it is what? White. If it is yellow in color, it is either lead 2 oxide or hydrated iron 3 salt present. If it is pale green color, it's either iron 2 salt present and hydrated nickel 2 salt. If it is blue color, copper 2 salt present. So copper is in blue. You know that. Black color is either oxide or sulfide of copper 2, iron 2 plus, iron 2 plus, okay, lead 2 plus, iron 2 plus, etc. That's copper sulfide, lead sulfide, copper oxide, iron sulfide, etc. These are the things you should try to streamline your mind to in terms of color. Remember, we talked about the first one, we talked about texture. Now, I've given you a sample. The sample is solid, all right? The first thing that comes to mind is either has a water of crystallization and so on and so forth because it is solid. If it is liquid, also you have your observation. Now, the next thing is, after you have observed that, the next thing is, what color does it exhibit? The color now is it white? If it is white, your mind goes to these ions here present. If it is white, it could be this ion. If it is yellow color, it could be this. If it is pale green color, it could be this. If it is blue color, it could be this, and so on and so forth. By that, we're able to narrow down into what the exact cation or anion of present in the salt is. By so doing, we wouldn't have much challenges in doing that, in getting our correct answer. And the last one here is, okay, if it is brown, it is, no space for that here. If it is brown, it's either iron 2 oxide or lead oxide or silver oxide or tin sulfide. If it is orange red, it is either chromate 6 salt. If it is orange red, it's either chromate 6 salt. So that is it about what color. So we're going to look at the smell. What smell does a sample possesses that will be able to give us an insight of we knowing what the salt is? So we're going to look into smell. So I can take this out now. Now, smelling a salt can also be used to detect the possible cations and anions present. All right. So let's say smell under observation and inference. So, in terms of smell under observation and inference here, we have one, smell of ammonia. It has a choking smell. So we know that ammonium salt is present. 2, smell of sulfur 4 oxide. It is irritating. You know, triazosulfate 4 is present. 3, smell of hydrogen sulfide. That is rotten egg smell. Once you perceive rotten egg, you know that sulfide is present. Alright? So now, that is our observation and inference on smell. Let's look at solubility. And after which we have, after solubility, I think we have some questions that we can answer on that solubility so that you begin to understand what you are anticipating or what you're expecting. So you will be more focused. So that is that about that. Now, in solubility, we say the solubility of a substance in solvent, that is water, is one of the ways of identifying a salt. Now, when I give you a sample, let's call it sample A, you put it inside what? Water. You're looking for the ways of identifying. You don't know what sample A is, only the instructor knows. So now, sample A has been given to you, which could be sodium triisocarbonate 4. Now, you make a solution of it. Put it in a small amount of water and see, is it soluble or insoluble? If it is soluble, you begin to now think or remember, how many of these kind of salts are soluble? All right. So first of all, before you get down to that, you have been able to identify the color. When you have a particular color, you know the kind of salt that will be present. Let's take, for example, you have copper. The color is blue. Your mind says it's copper. Okay, good. You are suspecting it's copper. Now, is copper, whatever, soluble in water or no? Not. If it is not soluble, you put it in water and see it is not soluble. Now you cannot confirm. Okay, obviously it's copper. But if it is soluble, copper is not soluble, then your mind goes to any other color similar, related to that blue. Alright? And so on and so forth. If it is white, the various cations that have white color, you've been able to streamline them out. Now, of these ones that are out, how many of them are soluble in water? You now check, only 1 or 2 is soluble. Okay, this one that is soluble. Okay, if the color is white and we have zinc is white, is zinc soluble in water? If it is soluble, you now say, oh, okay, zinc, but lead is not, for example. Do you understand? You begin to stream it down to the exact word, cation. These are various ways which we use to identify the cations present in solutions or in salt. All right, so let's go forward to see what happens in solubility. Okay, under solubility of salt in water, we say the substances that are soluble and substances that are not soluble. All triazonate 5 salts are soluble. So any compound that has to do with triazonitriphiles is soluble. Potassium triazonitriphi, calcium triazonitriphi, magnesium triazonitriphi, anything that has to do with triazonitriphi is soluble in water. So here, there are no insoluble salt of triazonitriphi. All of them are soluble. That's one. 2. All hydrogen triazocarbonate 4 salt are soluble. 3. All tetrazosulfate 6 salt except those of barium, calcium, argentum, and lead. So tetrazosulfate 6 of barium, calcium, argentum, and lead are insoluble. Which means if I have sodium which one there? Potassium tetrazosulfate 6 or is there magnesium? Magnesium tetrazosulfate 6 is soluble. And any other one you can figure out. Okay? All chloride except those of argentum, copper, lead, and hydrargyrium. All of them, all chloride are soluble except this one. So chloride, bromide, and iodide of argentum, copper, lead, and hydrargyrium are insoluble. So every other one is soluble. Triazosulfate 4 salts of sodium, potassium, and ammonium are soluble. All other triazosulfate 4 salts are insoluble. Triazocarbonate 4 salt of potassium, sodium, and ammonium are soluble. All other triazocarbonate 4 compounds are insoluble. Sulfite of sodium, potassium, ammonium, and calcium 2+. All other ones are insoluble. Oxide and hydroxide of sodium, potassium, and calcium are soluble. All other oxide and hydroxide are insoluble. Now, the knowledge of this is very important because you will be able to figure out what the cation or the anion is. Let's see, for example, if the questions were given, let's take exercise. They say you carry out solubility tests of the following salt and record your inferences. Ammonium salt. The example of an ammonium salt they gave us is ammonium chloride. Remember, they say, is it somewhere here talking about chlorides? All chlorides except those of argentum, copper, lead, and ammonium. Those are the ones that are insoluble. So, but all chlorides are soluble except these ones. And they gave us what? Ammonium chloride. So your test is ammonium chloride plus water. Observation. Substance or sample A is soluble, which is a soluble salt. Now, because ammonium chloride is soluble from what they have given to us here in water. So the observation is it is soluble. But if you do not know that all chloride except these ones are soluble, you will not know if ammonium chloride is soluble or not. I don't know if I'm making sense. So from here, from this rule now, you begin to know or you will understand that ammonium chloride is soluble. Let's take from sodium salt. Potassium chloride is soluble. All chloride. Potassium is soluble. Sodium chloride is soluble. Potassium tetrazosulfate 6. Now, we are in tetrazosulfate 6 salt. They say they are all soluble except this one. And we have potassium tetrazosulfate 6. Means it is soluble. If it is barium tetrazosulfate 6, you see it's not. From what we have here, potassium sulfate is soluble. Let's take mercury and silver salt. Now in mercury we have silver nitrate. Now let's nitrate. All chloride except those of these, all tetrazosulfate, all hydrogen triazocarbonate 4, all triazonitrate 5 salt. Now we have silver nitrate. They say all of them are soluble. So from here you begin to see that, oh, okay, from this rule, it is soluble. And you understand, you have to keep this in your head. You have to know that. So silver nitrate is soluble. Mercury chlorides, they say all chlorides, where are we? All chloride except those of hydrargyrium. Yes, hydrargyrium chloride. So this one is not soluble. And argentum, that is silver iodide. Okay, silver iodide. All chloride except those of silver. So we have silver iodide, so that one too is not soluble. Let's look at the carbonate salt. We have sodium triisocarbonate 4, triisocarbonate, or hydrogen triisocarbonate 4 are soluble, or triisocarbonate 4. We have lead triisocarbonate 4, calcium triisocarbonate 4. These ones are soluble. Now we have calcium chlorides. All chlorides, where are we? The chlorides. All chloride except those of, okay, calcium is soluble, see? And we have calcium sulfate. Okay, all tetraoxosulfate 6 salt except those of calcium is not soluble. Calcium sulfate is not soluble. So from here you begin to see that if I ask you, or perhaps you are being asked to identify the various salts, they can be given to you in their various names: calcium chloride, potassium, sodium, and so on. That if you identify those that are soluble and those that are not soluble, with your knowledge of the solubility table, you'll be able to identify those that are soluble and those that are not. It's as simple as that. But it is more important that you should have these in your head. You should be able to go through it, understand the basic principles. All right? When you do that, you wouldn't have challenges when you come across any of the compounds that will be given to you in terms of identifying whether it is soluble or it is not soluble. So we'll go down to flame test. Another major test. We say in the preliminary test, we are going to identify the physical properties, which are the texture, which we have done. In terms of the texture, with the physical property, we talk about the texture, we talk about the solubility, color, and odor. So the next major test is the flame test, and then we'll go to action of heat. So let's look at the flame test.